Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. How are you guys doing? Kenapa macam tak ramai je? Di manakah orang lain? Siapa yang dah sampai? Angkat tangan. Pixel tak cantik lah hari ni. Dia tak sharp. Hi, Dira. Good evening. Angkat tangan dah. Okay. Alright, so don't forget about your attendance, everyone. So jangan lupa key in attendance, Okay, so now let us start, I think. So kita tu start je lah. So I think your friend can go to the previous slide if they need to. So saya buka bagi penuh slide. Okay, so let us continue from the previous lecture. So higher order derivative. So occasionally it is useful to differentiate the derivative of a function. So in this context, we shall refer to f prime as the first derivative of f and to the derivative of f prime as the second derivative of f. Okay, so normally the second derivative, we write them down as f double prime. And if we have 3 prime, that means this is the third derivative of f or f triple prime. Okay, so now let us see this table. Okay, so basically the first derivative, you can write them down as y prime. Or you can use f prime of x, or you can write them down as dy over dx or d over dx of fx. So this is y double prime, so this is the second derivative, f double prime, so second derivative. So if you want to write them down in terms of dy over dx, it should be d2y over dx square. So the third derivative, y triple prime, f triple prime, and then this one should be d cube y over dx cube. Okay, so let us go to the only example to calculate the first, the second, and the third derivative of px. Okay, so calculate the first, second, and third order derivative of px equal to negative 2x to the power of 4 plus with 9x cubed minus with 5x squared plus with 7. Okay, so let us calculate the first derivative. So the first derivative will be p prime of x. Okay, so let us differentiate negative 2x to the power of 4 first. So bring the power down. So we are going to get negative x, negative 8x cubed. And then plus with differentiating 9x cubed. So bring the power down. So this is 27x squared. And then we got 2 times with negative 5. So this is negative 10x. And then differentiating 7, it will become 0. So this is p prime. So now let us calculate p double prime. Differentiate this again with respect to x. Okay, so bring the power down. So 3 times with negative 8. So this is negative 24x squared. And then 27 times with 2. So this is 54x. Differentiating negative 10x. So that one will become negative 10. Okay, so now let us differentiate them again to get p triple prime. So triple prime, it will become negative 48x plus with 54. Okay, so that's it for lecture 2 or lecture 9.2. So now let us proceed with lecture 9.3. Okay, so differentiation of exponential, logarithmic, and trigonometric function. So the objective is to determine the derivative of the function a to the power of x, a to the power of fx, e to the power of x, and e to the power of fx, as well as how to differentiate ln of x and ln of fx. Okay, so derivative of exponential function. So if let's say we have d over dx of a to the power of x, so that is actually equal to a to the power of x. So we're gonna copy down our exponent again, and then ln of the base. So this is a as our base, so we got ln of the base, and then you should differentiate the power x. So normally for me, I prefer the second formula where I'm using the general form. So if I have to differentiate d over dx of a to the power of something, what will happen is that I'm going to copy down the exponent together with the power first. So a to the power of that something, and then ln of the base, and then do make sure to differentiate that function. So that is how you get f prime of x. So normally I write them down as d over dx of a of something. So this is a of something, ln of the base, ln a, and then we should differentiate that thing. Okay, so now let us go to the example. So we differentiate the following with respect to x. So that means we are going to get dy over dx. Okay, so now differentiating 5 to the power of x. So let us refer to the formula. The formula said that if we have to differentiate a to the power of fx, then it will become a to the power of fx ln of a f prime of x. So in this case, we're going to copy down everything first. So it will become 5 to the power of x, and then ln of the base. So this one will become ln of 5 because we have 5 as the base. And then we should differentiate the power. So differentiating the power is x. Okay, so what will happen here is 5 to the power of x ln of 5. Differentiating x, it will simply become 1. So this is our final answer for A. So differentiating 5 to the power of x, again, simply copy down the exponential. So we got 5 to the power of x ln of the base. So since we have 5 as the base, so ln of 5. And then differentiating the power, so differentiate x, we are going to get 1. Okay, so let us go to the next one. Okay, so we got 4 to the power of 3x plus 5. Okay, so again, if let's say we have to differentiate a to the power of something, so it will become a to the power of something, ln of a, and then differentiate that thing. Okay, so this one will become 4 to the power of 3x plus 5, ln of the base, so we got 4 as the base, so this is ln of 4, and then we should differentiate 3x plus 5. So differentiating 3x plus 5, that will give us 3. So what do you have is 4, 3x plus 5 multiply with 3 ln of 4. Okay, so that's it for B. Okay, so now derivative of natural exponential function. So now we got e to the power of something. So almost similar, except that over here we have ln of e, and ln of e is actually equal to 1. So semua orang tahu kan, satu dunia tahu, dan satu dunia setuju ln of e is actually equal to 1. Okay, so now if you have e to the power of x ln e, and then differentiating x, so this is also 1. So differentiating e to the power of x is simply e to the power of x. So basically, if you have d over dx of e to the power of something, so simply copy down. So e to the power of something, and then ln of e, and then we should differentiate the power. But ln of e is actually equal to 1. So that is how you end up with e of something, and then differentiate the power. Okay, so done. Next, let us go to the example. Okay, so find dy over dx of the following. So we got two questions over here. Okay, so let us go to the first question. Okay, so what is the formula? Right, so basically if we have d over dx of e of something, so this is e of something, and then ln of e, and then differentiate the power. But ln of e is actually equal to 1. So this is e of something, and then differentiate the power. Okay, so over here we got e to the power of half x. So dy over dx, this is e to the power of half x. And then we should differentiate half x. So differentiating half x, this is simply equal to half. So we are going to get half e to the power of half x. Okay, so differentiate, kena differentiate elok-elok lah. Right, done. Next. Right, so we got y equal to 7, e to the power of negative 3x plus 5. Right, so again, differentiating e to the power of something. So this is e to the power of something, ln of e, and then we should differentiate the power. But ln of e is actually equal to 1. So this is e to the power of something, differentiate the power. Okay, so now what happened here? So dy over dx. So since you have some constant, simply copy down the constant. Okay, so now let us differentiate the exponent. So copy down the exponent, e to the power of negative 3x plus 5. And then we should differentiate negative 3x plus 5. Differentiating negative 3x plus 5, this is actually equal to negative 3. So we got 7e negative 3x plus 5 multiply with negative 3. And then we got some number here, some number here. So simplify them. So this is negative 21 e to the power of negative 3x plus with 5. Okay, so done with the exponential. So now let us proceed with the next one. Okay, so find the derivative of the following function. So we got y equal to xex, and another one is y equal to 3x plus 2 over ex. Okay, so do check out this one. So we got x times with e to the power of x. So this is definitely a product rule. So we should let one of them as u. So x will become u. E to the power of x will become v. And then we're going to differentiate them like what we did for product rule. For this one, this is a fraction. So we're going to have u over v. So that means for this one, we need to use some quotient rule. Okay, so basically, let me give you a few minutes for you to try them first, and then we're going to compare our answer together. Okay, so I'll give you around perhaps 5 minutes for this one, 5 minutes for this one. Altogether, discount kit, 8 minutes will do, I think. So I'll give you around 8 minutes for you to try to answer A and B. Do make sure to follow the rule exactly. And the time start from now. Just in case you couldn't remember the formula, the product rule is uv prime plus vu prime. Meanwhile, this is dy over dx. So this is for product rule. The quotient rule, dy over dx. vu prime minus uv prime over v squared. So this is quotient rule. This is product rule. 5 minutes to go everyone. Kalau dah siap boleh bagi tahu saya. Kita boleh cepat sikit kalau dah siap. Kau dah siap lah. Jangan aku dah siap lah. Kau tak siap lagi. Oh, dah siap dah. Yo, cepatnya. Beri saya bagi sampai 8 minit. Dah siap dah. Senang soalan dia. Kita tunggu orang yang ke 5 siap ke? Kalau dah 5 orang siap, kita boleh proceed. Okay, Dira, Asma, Fatha, baru 3 orang. Siapa lagi 2 orang? Aisyah siap. Okay, orang yang keempat. Okay, siap lah. Alright. So, thank you very much everyone. So, we can proceed straight away. Oh, senang soalan dia. Okay, so let us go to the first one. So, we got y equal to x e x. So, u will be equal to x, v will be e to the power of x. Okay, so we are using the product rule. So u v prime plus v u prime. So u is x, and then we're going to differentiate e to the power of x plus with v e to the power of x u prime. So we're going to differentiate the x later on. Okay, so now differentiating e to the power of x. So this is simply e to the power of x. Differentiating x, it will simply become 1. So what do we have is x multiply with ex plus with ex multiply with 1. And then of course you're going to factorize ex. So factorize ex outside. So we are going to get x plus 1 multiply with ex. Okay, so that is for A. So now let us proceed to B. Okay, so B, we got u equal to 3x plus 2. And then v is equal to e to the power of x. Okay, and then we're going to use the quotient rule. So v u prime minus u v prime over v square. So substitute into the formula. V is ex. And then we're going to differentiate 3x plus 2 minus with u 3x plus 2. Differentiate e to the power of x over v square. Okay, and then we're going to differentiate one by one. So differentiating d over dx of 3x plus 2, the answer for this is 3. Differentiating e to the power of x, the answer for this is simply e to the power of x. So let us simplify them. So 3ex minus 3x plus 2 ex over ex squared. And then of course you can actually factorize ex in order to cancel out with the v square. So to factorize out ex with ex, so we are going to get 3 minus 3x plus 2 multiply with ex. So that is how you end up with 1 minus 3x. Oops, this one should be minus. So negative 3x, negative 2. Okay, and then of course you should cancel out ex. Okay, so what you have left is 1 minus 3x over e to the power of x. Okay, so that is the final answer for B. Okay, so let us proceed again. Next. Okay, so this is the derivative of logarithmic function. So we have learned how to differentiate the exponential function. So this is logarithmic function. Okay, so basically you can actually differentiate them for all x greater than 0. The domain should be greater than 0. So if we do differentiate ln of x, we are going to get 1 over x. And if we have to differentiate ln of fx, so it will become f prime of x over fx. Or normally for me, I'll say d over dx ln of something. So whenever you differentiate ln of something, it will become 1 over that something. And then times with d over dx of the thing behind the ln. Okay, so that is how you end up with f prime of x over fx. So yang ini biasanya yang saya pegang lah. Normally I memorize this one. Okay, let us go to the example. Okay, differentiate the following function with respect to x. So let us do A. So we got ln of 3x. So do remember differentiating ln of something. So this is 1 over something. And then differentiate that thing. Okay, so differentiate ln of 3x. So this is 1 over 3x. And then we will differentiate 3x. Okay, so differentiating 3x, what is the answer? The answer for that is actually 3. So what do we have is 1 over 3x times with 3. And then 3 over 3, you cancel them out. So that is how you end up with 1 over x. Okay, so again, the formula d over dx ln of something, that is 1 over that something, and then differentiate that thing. So we got d over dx of ln 3x, so 1 over 3x, differentiate 3x. 1 over 3x, so simply copy down, differentiating 3x, it will become 3. So simplify 3 over 3, it will become 1, so we got 1 over x. Okay, next. Oh, dah termasuk kawasan dia. Okay, sekejap. Let me use another color then. Okay, so now differentiating half ln 5 minus 3x. Okay, so since half is simply a constant, so we're going to copy down the half. And then let us differentiate ln 5 minus 3x. So it will become 1 over 5 minus 3x. And then we are going to differentiate 5 minus 3x. Okay, so basically differentiating 5 minus 3x, that is actually equal to negative 3. So we got 1 over 2. Oops, tak muat tepat. 1 over 2. 1 over 5 minus 3x. And then another one. Negative 3. Okay, so what do we have is negative 3 over 2 times with 5 minus 3x. Okay, so that is basically the answer. Negative 3 over 2, 5 minus 3x. Okay, next. Right, so find the derivative of y. So y equal to x ln x, and then y is equal to ln x over ex. So again over here, we got a product x times with ln x. So one of them will become u, one of them will become v, and then we're going to use the product rule for them. And then for this one, we actually have a quotient. So this one will become u, this one will become v. So we are going to use the quotient rule for them. Okay, so again, I'll give you a few minutes for you to try them. So, saya bagi 38 minit 5 minutes lah. 5 minutes first. And then, once 5 minutes up, if you still couldn't solve them, then let me know. I'll add a few minutes more. Oh, forgot. Let me write down the formula for you. Product rule u v prime plus v u prime. This is v u prime minus u v prime over v square. Kalau dah siap, boleh cakap dah siap, and then we can proceed to the answer. Kalau dah siap, kita proceed the answer lah. Oh, siap lah. Weh, cepatnya. 1, 2, 3, 4. 4 orang dah siap. Let me wait for one more person. Sebab sebenarnya kalau 5 orang tu ramai dah lah. Oh, tiba-tiba dah ada dah. Okay. Right, so now let us see the answer then. Okay, so x ln x. So we're gonna let x as the u. So x will become the u, ln x will become the v. And then we're gonna use the formula u v prime plus v u prime. So we got x, and then differentiate ln x plus ln x, differentiate x. So differentiate ln x, we have learned this previously. So this is actually 1 over x. Differentiate x, we are going to get 1. Differentiate x, we are going to get 1. So what do we have is x multiplied with 1 over x plus with ln x, and then to make sure to simplify x over x. So what is the answer? The answer is 1 plus ln x. So that is the answer for A. Let us go to B. So B, we got ln x over ex. So ln x will become the u, ex will become the v. And then we're going to substitute into the formula. V u prime minus u v prime over v squared. So the v is e to the power of x. And then we're going to differentiate ln x minus ln x, differentiate ex. Okay, so differentiating ln x, so this one will give us 1 over x. Differentiating e to the power of x, so this is simply e to the power of x. Okay, so what do you have is 1 over ex squared, and then we got 1 over x times with ex minus ln x ex. Okay, so what should we do next? So normally for me, I prefer to factorize ex first. So let us factorize that. So what are we going to have next is 1 over ex, 1 over x minus ln x. Okay, so once you factorize ex over here, you're going to end up with 1 over x minus ln x over ex squared. And then since you see this is ex squared, so that is how you cancel out ex and ex squared. And you are going to get 1 over x minus ln x over e to the power of x. Okay, so I think we are done with this one. So let us go to the trigonometric function. Okay, so for trigonometric function, you should be able to determine the derivative of sine x, cos x, tangent x, and etc. Sine u, cos u, tangent u, etc. And whenever we have sine to the power of something. So this one is quite basic. So we have everything with x. For the second one, that simply means that you have another function rather than x over here. So perhaps sines of x squared and etc. So sine to the power of nx. So that means instead of having sine x, you are going to get something like sine square or sine cube or sine to the power of 4. So that is what they mean over here. Okay, so let us go then. Right, so these are the basic thing that you need to know. If we differentiate sine x, we are going to get cos x, a positive cos. Differentiating cos x, we are going to get a negative sine. Differentiating tangent x, we are going to get secant square x. Differentiating cotangent x, we are going to get negative cosecant square x. Differentiating secant x, it will become secant x tangent x. Differentiating cosecant x, it will become negative cosecant x cotangent x. Right, so basically these three will be given in your exam. You only need to memorize A, B, and C. Okay, next. Right, so this is basically if you have u equal to fx. So instead of having sine of x, we are having something like sine of fx. Okay, so for me, I do memorize them as differentiating sign of something. So differentiating sign of something, like what we know previously, this is cos of something. And then do make sure to differentiate the function later on. So differentiate sign of something, it will become cos. So this is when we differentiate sign, we are going to get cos. And then do make sure to differentiate whatever function you have inside the cos. So same thing over here. If we have to differentiate cos of something, so differentiate the cos first, it will give you negative sign. And then take whatever the function is. But don't forget, you got to differentiate the function at the back. So same thing over here. If we have to differentiate tangent of something, so firstly, it will become second square of that thing first. And then don't forget, you have to differentiate them later on. Okay. Right, so almost similar to what we have previously. So I'm not going to go through them. The next one. Okay, so differentiate the following with respect to x. So the first one, we got 2 sine x minus 3 cos x. The second one, we got 4 tangent x minus 5 over x. Okay, so let us differentiate the first one. So differentiating 2 sine x minus 3 cos x. Okay, so what happened if we differentiate sine? So we are going to get cos. So for this one will become 2 cos of x. And then don't forget, you have to differentiate x. And then minus 3, differentiating cos, we are going to get negative sine of x. And then differentiate x. Okay, so differentiating x, it will simply become 1. So we are going to get 2 cos x. And then differentiating x over here, that is also 1. So 2 cos x plus 3 sine of x. Okay, so again, 2 sine x. So differentiating 2 sine x, 2 is simply a constant. So bring them in front first. Differentiating sine, it will become positive cos. So cos of whatever the function is. And then we should differentiate that function. And then take the constant out. So negative 3, differentiating cos, we are going to get negative sine. Differentiating whatever function we have at the back. So differentiating x, it will simply become 1. So that is how we end up with 2 cos x. Negative 3, negative sine x. So it will become positive 3 sine of x. Okay, so once we are finished with that, let me erase this so that we can see the answer. Okay. Right, so B, we got 4 tangent x minus 5 over x. So normally for this one, I prefer to change this to become 5x to the power of negative 1. Normally, I prefer to change it into power so that I can use the power rule much more easier. Okay, so differentiating 4 tangent x first. So we got to differentiate 4 tangent x minus 5 over x. So when we differentiate, if we have some constant, simply copy down the constant. Differentiating tangent, so it will become second square, whatever that function is, so second square x. And then don't forget, you have to differentiate the x. Oops, okay. And then differentiating negative 5x. So this is actually negative 5 x to the power of negative 1. So we are going to get negative 5 times negative 1 x to the power of negative 2. So we're going to bring the power down. So it will become negative 5 times with negative 1. Copy down the x, but then you have to deduct 1 to the power. So it will become negative 2. So this one, it will become 4 second square x, negative 5, positive 1. So it will become positive 5 over x squared. So we got 4 second square x plus 5 over x squared. Okay, next. Right, so find the derivative of sine ln x second to x plus 3. Okay, so firstly, let us differentiate sine of ln x. Okay, differentiating sine, it will simply become cos. So this one will become cos whatever that function is. So cos of ln of x, cos ln x. And then times with differentiating the function itself. So we're going to differentiate ln x. Okay, so again, differentiate sine. We are going to get cos. Take whatever that function is, simply copy down ln x. And then we're going to differentiate that function. Okay, so this one, you simply copy them. So this is cos of ln x. Differentiating ln x, it will become 1 over x. So what do you have is cos ln x over x. Yang ni jangan potong pula lah. Tak boleh potong sebab ini ada function kat depan. Okay, so now the second one. So the second one, we got second 2x plus 3. Okay, so d over dx of this. Okay, so differentiating second, it will become second tangent. So we got second of 2x plus 3, tangent of 2x plus 3, and then you should times them. So multiply with d over dx of 2x plus 3. So times them with d over dx of 2x plus 3. So copy down second, that function, tangent, that function, and then we're going to differentiate that function. Okay, so differentiating 2x plus 3, it will simply become 2. So we got 2 second, 2x plus 3, and then tangent 2x plus 3. Okay, so done with that as well. So let us proceed with the next one. Okay, so for this one, if let's say we have some power. Okay, so do make sure to use the special power rule. So if we have to differentiate fx to the power of n, so it's like differentiating something to the power of n. So firstly, we bring the power down first, copy down whatever that function is, deduct with 1, and then we're going to differentiate the function. Okay, so that means if you have sine to the power of n, u, we're going to treat them like if we have sine of u to the power of n. So we're going to bring the power down first, copy down the function sine of u, but then we deduct 1 to the power, and then we're going to differentiate the function. So that is how you end up with cos of u. Right, never mind. I think you're going to see them better if we do the example. But that is basically how we're going to solve them. So we're going to use the special power rule for them. So if let's say you have sine square of x, so we're going to change this into sine of x square, and then we're going to differentiate them just like what we did over here. Okay, so let us go to the example. Okay, so differentiate each of the following with respect to x. Okay, so the first one, we got y equal to sine cube x square plus with 1. Okay, so what do we do first? Alright, so firstly, do make sure to take out the power, bring them out. So we have sine of x square plus 1 to the power of 3. So this is y. And then, if we do differentiate something with power, what happens is that we're going to copy down the power, copy down the function, deduct 1 to the power, and then we're going to differentiate the power. Oops, the function. Okay, so copy down the power, and then the function, deduct 1 to the power, and then we're going to differentiate the function. Okay, so now dy over dx. Okay, so bring down the power first, so 3, and then copy down whatever we have, so sine of x squared plus 1. But instead of 3, we're going to deduct 1 to the power, so it will become 2. Oops, 2. And then we're going to differentiate sine of x squared plus 1. Okay, so this one, we're going to simply copy them down. So this is 3. This one, you can write them down as sine square x square plus 1. So now let us focus on how to differentiate sine x square plus 1. Okay, differentiating sine, we are going to get cos. So this one will become cos of x square plus 1. But then I have to differentiate x square plus 1. Okay, so do remember, if we have to differentiate sine of something, so it will become cos of something, and then differentiate that thing. Okay, so differentiating sine, that is how I end up with cos x square plus 1, and then we are going to differentiate x square plus 1. So differentiating x square plus 1, it will simply give us 2x. So this is 3 sine square x square plus 1 multiply with cos x square plus 1, and then differentiating this, it's gonna give you 2x. So what do you have is 3 times with 2x, so it will become 6x sine square x square plus 1 multiply with cos x square plus 1. Alright, so that is how we do A. Okay, so now let us see B. Okay, so B, we have cotangent square of 3x, right? So better to write them down as cotangent of 3x square. So this is y. And then we're going to use the formula. So basically, if we have to differentiate a function to the power of n, so this is n, copy down the function, deduct 1, and then we are going to differentiate the function later on. Okay, so I'll give you 2 minutes for you to try to differentiate them. Oh, siap dah. Saya cu dah korang. Okay, so now let us use the formula for this. Okay, so what will happen? It will become 2 cotangent of 3x, and then negative cosecant square of 3x multiply with 3. So it will become negative 6 cotangent of 3x, and then cosecant square of 3x. Okay, so this one cosecant 3x square, use the power rule, so this is 2 cotangent of 3x to the power of 1, and then differentiating cotangent of 3x. Differentiating cotangent, we are going to get negative cosecant square 3x, and then this is what happened when we differentiate 3. Okay, and then you simplify the 2 together with the negative. So negative 2 and 3. So that is how you end up with negative 6. Cotangent of 3x, cosecant square 3x. Okay, next. So find the first derivative of the function given below. So the first one, we got x squared, ln of 3x plus 1. Another one is the square root of x squared plus second 2x plus with 3. Okay, so now I'll give you 5 minutes. Will that do? 5 minutes for you to try them. So untuk siapa-siapa yang tak ada idea, this one you got x squared times with a ln. So you got two different function over here. So x squared and then a ln. That means this is basically a product rule. You need to apply the product rule for them. So with this one, we got x squared plus second 2x plus 3. And then this is basically to the power of half. So that means for this one, you need to use the special power rule for them. So bring down the power, copy down the function, deduct 1, and then don't forget to differentiate the function later on. So the first one, product rule. The second one is simply the special power rule. Asal makin lama makin kurang like video ni. Lawa lah rasa. 3 minutes to go. Satu minit 30 saat lagi. One minute and 30 seconds to go. How are you guys doing? Almost finished? Nearly there? Ataupun masih tak nampak sinar? finish B tak nampak sinar. Never mind. We got 30 seconds to go. Start dekat B. Oh, A tu senang Oh, okay. Oh, Fatin Hani siap dah. Okay. Dan boost ke Fatin? Dira pun siap dah. Okay. 20 seconds. Okay, so 5 minutes done. So let us see then your solution. And let's see what happened. Okay, so basically we got x squared ln 3x plus 1. So we're going to let u equal to x squared ln 3x plus 1. That one will become our v. So this is u v prime plus v u prime. So u is x squared, differentiating ln of 3x plus 1. So we are going to get 3 over 3x plus 1. Do you guys know how? So we got ln of something, right? So differentiating ln of something. So it will become 1 over something and then differentiate that function. Okay, so 1 over 3x plus 1, differentiating 3x plus 1, that is how we end up with 3. And then plus ln 3x plus 1 and then differentiating x squared. So that is how we get 2x. Okay, so if you take out the x or you factorize the x, you are going to get x 3x over 3x plus 1 and then plus with 2 ln 3x plus 1. Okay, so done with A. B. This one terus dia bagi satu solution. Okay, so we got a square root of x squared plus second, x squared second of 2x plus 3. So like I told you before, we change it into power. So we got x squared plus second, 2x plus 3 to the power of half. And then we're going to apply the power rule for them. So bring down the power first. So that is how you get half. And then copy down the function. So we got x squared plus second, 2x plus 3. But then deduct 1 to the power. So that is how you end up with negative half. And then differentiate x squared plus second, 2x plus 3. Okay, so the thing in front, benda yang kat depan ni, that's nothing. You can simply copy them down. But just be very careful with the term on the right hand side. Okay, so differentiating x squared, we are going to get 2x. I think that is quite easy for you. Differentiating second, so this is like if we have differentiate second of a box. So this is second, tangent, and then differentiate the box. Okay, so it will become second 2x plus 3, tangent 2x plus 3, differentiating 2x plus 3. That is how you end up with a 2. And then we factorize the 2 outside because we can see a 2 here, a 2 there. So we factorize 2 outside. So we are going to get x plus second 2x plus 3, tangent 2x plus 3. And then we actually have a half over here. And then we have a 2 behind here. So we can actually simplify them. So half times 2, that is actually equal to 1. So we are going to get x squared plus second 2x plus 3 to the power of negative half times with x plus second 2x plus 3 tangent 2x plus 3. Or you can write them down as x plus second 2x plus 3 tangent 2x plus 3 over the square root of x squared plus second 2x plus 3. So, yang atas ni boleh, yang bawah ni pun boleh lah. Either one. Either one will do. Saya tulis insert. Is it okay? Yes. You can actually write them down as set, something like this. But do make sure to bring them down because we have negative as the power. Okay. So let's see, do we have any more questions? I don't think so. Oh, we got another one, but never mind. Okay, so this one, I'll leave that as your homework and then we're gonna check them later on. So nanti hari Selasa lah kita check So on Tuesday, I'm gonna check this one together with you. Okay, so with that, I'll see you guys this coming Tuesday. Thank you very much for listening and goodbye everyone.